Hi, this video will explain how to make an op-amp or operational amplifier work as either an inverting or non-inverting voltage amplifier. If you're not familiar with op-amps and would like a general overview, then there is a video in the description below. But to summarise, an op-amp's goal is to make the output the difference between its two inputs. This effect can be used in various ways by adding different components across its terminals, usually resistors. This circuit here is what's known as an inverting amplifier. As you can see, I have a 1 volt DC supply going through a 1 kilo ohm resistor onto what's called the inverting input, with another 1 kilo ohm resistor across the inverting input and output. Having a connection between the output and the input of an op-amp is known as feedback. Then finally, if you look at the voltmeter at the end of the circuit, we're getting an output voltage of -1 volts. This is why this is known as an inverting amplifier. If I now increase the value of this second resistor to say 2k, we'll see the output doubles to -2 volts. Let's see what's going on here in detail. This is the equation to calculate the gain of an inverting op-amp. Gain just means the amount the input is multiplied by. Looking at this equation, we can see that R2 and R1 have a relationship, where the bigger R2 divided by R1 is, the bigger the gain. And finally, we have to remember the minus sign over here, which denotes this as an inverting amplifier. Let's try this out in practice. If I now increase R2 to say 6k and R1 to say 2k, we'll see the output becomes -3 volts. Well, 6 divided by 2 is 3. In other words, R2 divided by R1 is 3, adding the minus sign, denoting it as an inverter. The other type of simple amplifier configuration for an op-amp is the non-inverting amplifier. In this circuit, we have a 1 volt DC supply, the same as the last simulation, only this time it's connected straight to the non-inverting op-amp input over here, the plus sign. We also have 2 resistors, one across the output and the inverting input over here, and one connecting the inverting input to the ground, both with a value of 1k. And then finally, there's a voltmeter across our output. Now curiously, the voltmeter is currently reading 2 volts, even though both our resistors are at 1k. Let's look at how to calculate the gain for a non-inverting amplifier. This equation may look similar to the inverting amplifier gain equation, but there are a few key differences. Firstly, the output is not inverted, in other words there's no minus sign over here. Secondly, the resistors are the other way around, so R1 divided by R2 instead of R2 divided by R1. And finally, within the brackets that give us the op-amp gain, we have to add 1 over here. This would help explain our previous circuit, as we have R1 and R2 both as 1k, which would mean 1 divided by 1, which is 1. Then adding 1 to that would give us the output of 2, which is exactly what the voltmeter displayed. Let's go back to our circuit and look at some other examples. If I now set R1 to a value of 2k over here, we will see that our output of 2 divided by 1, which gives us 2, plus 1 gives us 3 volts. If I now do the same as I did with the inverting amplifier and set this resistor here to 6k and this one to 2k, we get 6 divided by 2, which is 3, plus 1, which is 4 volts. Additionally, if we go back to the inverting amplifier and set this resistor here to say 10k over here, the equation is now 1 divided by 10, which gives us 1/10. As we can see, we get 100 or -100 millivolts on the output. This means an inverting amplifier can be used for gains less than 1. However, going back to the non-inverting amplifier, due to the +1 in the equation for non-inverting op-amp, it is impossible to make a non-inverting amplifier that has a gain of less than 1. Even if I set this resistor to a really low value, all the way down here, and this resistor to a really high value, all the way up here, we can see the simulation comes out as roughly 1 volt. If you really need a gain of less than 1, then you may have to consider a voltage divider. There is a link in the description showing you how to build one. Or, if your circuit has a high resistance, you may need to include a voltage follower, link also in the description. Inverting and non-inverting op-amp circuits are probably the most popular op-amp configurations and are definitely worth knowing. Thanks for watching, be sure to like the video if you liked it, subscribe if you loved it, and have a good day. See ya!